Alrighty, hello, wherever you're coming from. I hope that you're feeling good and comfy and cozy. We're going to keep working through this Peardeck together, and this is all on different properties of exponents. So the next one that we see here is the power of a quotient. So this is similar to power of a product, only it's when we have, two terms that are being divided and they're both raised, and that whole fraction is raised to an exponent, we want to make sure that our numerator gets the exponent and our denominator. So we're just going to draw an example here. So if we have something like x over 3, and that whole fraction is squared, this means this exponent of 2 has to go to the numerator, so we're going to get an x squared, but it's also going to go to the denominator, so we'll also get a 3 squared. So we're just distributing that exponent, which this one just be x squared over 9. Perfect. We can also look at another example of 4y divided by 2. Well, not 2. We'll do 5. And that whole piece cubed. So the numerator is 4y cubed, and our denominator is just 5 cubed. 4y cubed, well, 4 to the third power is 64, right? And again, remember that's 4 times 4 times 4, 3 times. So we have a 64 y cubed divided by 5 cubed. 5 times 5 times 5 is 125. So just kind of showing you that when we have a quotient like this, we want to make sure both the top and the bottom are getting that exponent. Okay? Alrighty. Let's go to the next slide. The negative exponent rule. This one is any term raised to a negative exponent is equal to its reciprocal raised to that positive value of the exponent. So when we have a negative exponent, we do the reciprocal and we make the exponent positive. So this negative a becomes a positive a, and it also moves into the denominator. So if we have 3 to the negative 2 power, this becomes 1 over 3 squared. It becomes a positive 2, and 3 squared is 9. 3 times 3. If we have a y to the negative 5th power, we do the reciprocal, flip it to the bottom, and make that exponent positive. So this is our negative exponent rule. We take our term, find the reciprocal, which is just flipping it to the denominator, and then making the exponent positive. Okay. Let's go to slide 10. I think this is our last one. Yeah. So this is the last exponent property. I know there's kind of like a lot. I think this is maybe our 7th or 8th. There's a lot of them that we talk about. And this last one is fractional exponent property. So any term raised to the fractional exponent, like m over n, is the same as taking the nth root and raising it to the mth power. So the big thing here, let's look at these examples, is if we have x to the m over n. The way that we think of that fractional exponent, which again just means that our exponent is a fraction, is power is on top divided by root on the bottom. So this is our power is m, so we're going to see that here, raised to the m power. And our root is n. So we're going to see that out front here for the root. So if we have something like x to the 3/4, right? Our power is 3 and our root is 4. So this is the 4th root of x to the 3rd power. So notice where we're putting. Here's my, oops. Here's my power. Here's my root. Let's do another one. If we have a y to the 7/9 power, so we have a fractional exponent. So power over root. The root is 9. It's the 9th root of y to the 7th power. So again, here's our root. And here's our power, like so. So we can rewrite and also simplify by using this idea that we can take anything that's in a root, like for example, x to the 1/2 has a power of 1 and a root of 2. So that's just the square root of x to the 1st power. So we can take roots and rewrite them as fractions and then use that as a way to simplify. So it's just important to see how we can kind of go back and forth between these two different types of ways to write our terms, using a fractional exponent or putting it in our radical form. Beautiful. Now for the next 4 slides, we're going to do some practice using all of this, kind of just reviewing everything that we've talked about. X to the 4th times x to the 6th, they both have a base of x and they're being multiplied. So we add the exponents. So this is x to the 4 plus 6, which is x to the 10th. Two x to the 4th all cubed. This is power of a product. So we want to make sure that we're doing 2 cubed. And then we're also doing x to the 4th cubed. 2 cubed is 2 times 2 times 2, which gets us 8. And x to the 4th cubed is power of a power, so we multiply when there's 2 exponents like that, which gets us an x to the 12th. So this all simplifies to 8x to the 12th. 3/4 cubed. Well, we're going to take, this is power of a quotient. We want to make sure the numerator is cubed and then the denominator. So we have 3 cubed divided by 4 cubed. 3 cubed, 3 times 3 times 3 is 27. And 4 cubed, we just did that one before, was 64. Last one again, we have power of a quotient, so we have this whole big fraction that's all being squared. So we need to make sure all of this is getting distributed. First, I'm gonna say, hey, let's simplify x to the first times x cubed. They both have the same base, they're being multiplied, add those exponents, and we get an x to the 4th divided by a y to the 4th, and that's all squared. So when we do power to a power here, we're going to multiply. So this is x to the 4th squared, which is x to the, well, I'll write it out into 2 steps. So we have x to the 4th squared, and then we have a y to the 4th squared. And each time we're going to multiply those exponents. So we get an x to the 8th divided by y to the 8th. Pause the video if you need to, get everything that you need on this slide. And when you're ready, push ahead to slide 12. So we have x to the 5th cubed. This is power to a power. When we have 2 exponents like this, we multiply. 5 times 3 gets us 15. So it's x to the 15th. 3x to the 5th, 3 times x to the 5th squared means this squared has to go to the 3 and then to the x to the 5th. So we have 3 squared times x to the 5th squared. Well, 3 squared, 3 times 3 gets us 9. And x to the 5th squared, multiply those exponents, becomes x to the 10th. 2 squared times 2 cubed, they both have a base of 2, and they're being multiplied. So we're going to add those exponents, and that's going to become 2 to the 5th. And we could simplify that, 2 to the 5th power, which again, remember, means we have 5 times. So we get 32. 2 times 2 times 2 times 2 times 2. So this just equals 32. Last one on this slide, x to the 6th times y to the 5th divided by x cubed times y squared. So we want to look at our bases that are the same. These are being divided, so we're going to subtract the exponents. So we have x to the 6, minus 3 times y to the 5 minus 2. 6 minus 3 gets us an x cubed. 5 minus 2 gets us a y cubed. So this is just x cubed, y cubed. Beautiful. Nice job, y'all. Slide 13. X to the 12th divided by x cubed. So these have the same base. They both have a base of x, and they're being divided. So we subtract the exponents. 12 minus 3, we get x to the 9th. 5x cubed y squared, all cubed, means this cubed on the outside has to go to every single part. So we have a 5 cubed. We have an x cubed cubed. And we have a y squared cubed. 5 cubed is 125. X cubed cubed, multiply those two exponents, gets us an x to the 9th. And multiply 2 times 3 gets us a y to the 6th. 3 to the 1st times 3 to the 3rd. They both have that base of 3. We keep the base. And since they're being multiplied, we're going to add these exponents. So this becomes a 3 to the 4th, which we could type into our calculator. And that gets us 81. X to the 4th divided by x to the 0. Well, anything to the 0 power is just 1. So this is just 1. And x to the 4th divided by 1 is x to the 4th. We could also use our quotient property here. Since they're divided, they have the same base. 4 minus 0 is just 4. It's going to stay as x to the 4th. Beautiful. Last slide for practice, slide 14. X to the 14th divided by x squared. They have the same base and they're being divided. So we're just going to subtract. 14 minus 2 gets us an x to the 12th. 2x cubed squared. So we have a 2x cubed that's being squared divided by a 3y that's being squared. Distribute that 2 squared and x cubed squared gets us 2 squared is 4 and x cubed squared, multiply those exponents, gets an x to the 6th. Divided by 3y squared, so 3 squared is 9 and y squared is just y squared. Beautiful. 3 to the 1st times 3 to the 3rd. First, simplify that numerator. 1 plus 3 is going to get a 3 to the 4th divided by 5 cubed. Nothing we can do there. These are different bases, so we can just leave it like that. And our final one is 3 times x to the 4th squared. Gets us 3 squared, which is 9. X to the 4th squared is x to the 8th. And then we also want to make sure that 2 goes down to the denominator, and 1 times 2 is 2. So we have a y squared. Beautiful. There is a check-in slide on slide 15. Make sure you're filling this out too. Take care. Talk to y'all next time. Bye.